It's math time with Heinz. It's math time with Heinz. Math time.
Everybody, welcome to lesson 9, where we're going to continue solving these 3x3 linear systems of equations. So let's start with this opening exercise here. Solve the following system of equations. So when we solve these equations, I like to have this 5-step structure here to kind of keep me organized, keep my steps organized so I know what's going on. So I need to look at these 3 equations and realize what variable is the easiest to eliminate. X doesn't seem too bad to eliminate, but Y seems even easier. So if I do top and bottom here, if I combine the top and bottom, my Y's will automatically eliminate. So I get negative 2x, those make 0, plus 7z equals negative 15. So I got rid of y. I'm going to come over here to this other top piece and get rid of y again. So I'm going to pick 2 different equations and see if I can get rid of y again. And I'm going to do second and third here. But I need to multiply this top one by 5. So in my head, I'm multiplying everybody by 5. Times 5 times 5 times 5 times 5. Always good to just check that over, because these problems aren't too hard, but the minute you make a mistake, you're done for. You are done for. It is a disaster at that point. All right, so now I have these 2 linear equations of only 2 variables. So I'm going to come down here to this lower box and pretend I'm in 9th grade land. I'm going to pretend like I'm in 9th grade, back with Mrs. Dolan or Mr. Holzapple or me or Mrs. Klein, and we're going to have a nice little 9th grade problem. We're going to zoom in on this and forget all that craziness. How do I solve this system of equations? Well, I've got to multiply this guy by negative 3 to do elimination again. So I eliminate, I get 4z equals negative 4, so z equals negative 1. Again, I'm still in 9th grade land. I don't get to zoom back out. I've got to plug him into one of these 2 here. Negative 2x plus 7 times negative 1 equals negative 15. So we plug it into one of our 2 variable equations and solve from there. Add the 7 and divide by negative 2. So the purple here is a 9th grade algebra problem, even 8th grade problem. Do elimination, get one of the variables, plug it in to get the other. Now we get to go back up to algebra 2 land, where I take both of these and plug them in. Doesn't matter which one I plug them into, but I need to pick my favorite equation of those 3 and plug it in. I'm going to do the top one. Negative 6, I know what x is, plus 5y plus 2z equals negative 11. So 5y minus 26 equals negative 11. So I add 26 to both sides. 5y is positive 15, so y equals 3. So my solutions are those values there, and if you wanted to write an ordered triple, it would be x, y, z. And I will make a separate video, because this computer I'm on right now doesn't have the calculator. I'll make a separate video walking you through how to do this on the calculator. Do we always get a solution? So when we solve these, do we always get a solution? All right, so who am I going to eliminate here? Let's eliminate, I don't know, maybe the x's. They're all pretty straightforward. Let's try the x's. Yeah, let's do that. Let's do top and bottom. So I'm going to double this first guy. So 4x minus 8y plus 2z equals 6. And I'm leaving this guy alone. So those eliminate. those actually eliminate too. And I get, what do I get here? I get negative 7y equals 8. All right, that's negative 8. That's a little weird. Let's pick another. Let me pick these two here and see what happens. Let me pick those two there and see what happens. So I need to double the bottom. I need to double the bottom. This is not starting off well. This is not starting off well. Doubling the bottom. Goodbye. Oh. 0 equals negative 21. This is not a true statement. This is false. This is not true. So this right here, back in 9th grade, we learned this means there are no solutions. There are no solutions to this system of equation here because that weirdness happens right there of 0 equals negative 21. Everybody go, ooh. So most of the time this doesn't happen. Most of the time I want to see all this beautiful work here. But know that that is an option when you solve a system of equations. Because what are we finding here? When in Algebra 1, we were finding the intersection of two lines when we did this, right? In 9th grade, we were finding where do these two lines cross. So now that I'm in 3 variables, that means I'm in 3 dimensions. So what are we finding? We're finding the intersection. Well, what's the 3-dimensional version of a line? Well, that's a plane. We're finding the intersection of 3 planes is what's really going on here. We're finding the intersection of 3 planes. So here I've graphed, I don't know why there's number 2 there. There's a big number 2 here. Here I graphed those 3 planes from that one with no solutions. So you'll notice there are these blue kind of rectangles that go on forever. And notice why there's no intersection there. There's no intersection because 2 of my planes were parallel. These 2 planes are parallel, so there's no point where all 3 of them intersect. So what are we doing is if you look on the front cover of your book here, we're finding that point of intersection. In this case, it didn't exist because those 2 planes were parallel. So we're finding the intersection of 3 planes. That's what we're actually doing when we solve this system of equations. All right, let's try this one. Let's try this one here. See how we do. Those 2. Let's get rid of, I think I want to get rid of x. Yeah, let's get rid of x. I'm going to multiply the top by 4. Again, you don't have to get rid of x. There's other options. Became a 2. That should be a 4. Negative 4y equals 0. Okay, this is another weird one. I got another weird one here. Let's try these guys here. I'm going to multiply the top by negative 3. Negative 3. Negative 3. Negative 3. Goodbye, 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 goodbye. 0 equals 0. So what this tells me here is I have infinitely many solutions. It'd be nice if I could spell infinitely. Infinitely, close enough. Infinitely many solutions. The way that my planes line up here is they just don't cross at one point. They cross at many points. It crosses at a line. This tells me here my points of intersection, my solution is actually a line, and that's way beyond the scope of our class here. That's for future linear algebra classes. We are not going to talk about that. But there are infinitely many solutions to this problem because you got 0 equals 0. When I had 0 equals negative 21, that's nonsense. That's no solutions. But 0 equals 0 tells me I have something going on here. I just don't know exactly what it is. We got it on your own. Pause the video and see if you can try this one, and then we'll watch it together. We'll watch the solution together. Here we go. Oh, it didn't go. There we go. All right, let's pick 2. I'm looking at, I think my X's. I think my X's are the way to go. I'm gonna do top and bottom and change bottom sign. I'm gonna do top and bottom and change the bottom sign. Everybody's sign gets changed. So 6y minus 3z equals negative, what is that? Negative 33. And then I'm gonna do those two. Doesn't really matter which ones I picked. I'm gonna times negative 2, times negative 2, times negative 2, times negative 2, times negative 2. So I get 9y minus 7z equals, that's a pretty big number, negative 57. But notice this one here, when I write this one again, I'm going to divide everybody by 3. I'm going to write 2y minus z equals negative 11. I divided everybody by 3 there because I can. I just kind of cleaned it up and made it a little bit simpler. Part of me thinks I have a mistake somewhere in here, and that's just embarrassing. I'm going to multiply that by negative 7. So negative 14y plus 7z equals positive 77. Fingers crossed here that things work out nicely. They do. Y equals negative 4. And again, I'm still in 9th grade land. I've got to plug that back in. 2 times negative 4 minus z equals negative 11. Negative z equals negative 3, so z equals 3. And now I take both of those values and plug them into your favorite equation back up here at the top. I'm going to use the top one. X plus 2y minus 2z equals negative 15. So x minus 8 minus 6 equals negative 15. X minus 14 equals negative 15. So x is negative 1. So my order triple here, neg x, y, z. That is the point of intersection of these 3 planes. These 3 planes intersect at that point, which I have here for us. These 3 planes intersect, if it's going to load. Oh no, it's cranky. Uh-oh. No, it does not want to. Oh, there we go. These 3 points intersect. These 3 planes intersect at that nice point right there. So notice, I got to find it for you. There's that point A, I labeled it. It's kind of hard to see, but that's where that's the best view right there. That point right there, which is the point negative 1, negative 4, 3, is where those blue rectangles, those 3 blue rectangles intersect. So we found the one point of intersection of those 3 planes. And I'll see you guys in the next video.